So as we said that the circuits are a combination of diodes and resistors only, let's understand the basics of diodes real quick, which we have already done in our lower classes. So this is my PN junction diode where I have shown cathode, anode, I have shown the direction of my current. And I also know that in my forward bias, if my voltage is greater than 0.7, my diode will conduct. In the reverse biased, my current would be nearly equal to 0. However, if a reverse bias diode is used at a voltage around Zener voltage, then we know that the diode breaks down, or the breakdown occurs in the diode at the Zener voltage when V is equal to minus Vz. How do we have the value of Vz, or how do we control the value of Vz? That is set by the doping levels and the characteristic of the junction, PN junction, which again we have seen in the lower classes. So what we are trying to understand here is, we are going to use this phenomena of the diode for input protection circuit. When it's forward bias, it will conduct, we know that. Ideally, in the reverse bias condition, the current is 0, but at a suitable voltage, say the Zener voltage, now after this, the diode will break down. And you can see the value of current which flows across through the diode in this case. So using this phenomena, let's understand our first input protection circuit, which is a combination of diodes and resistors only. Here I have shown two diodes, R1 and R2. And I have just made resistors. A lot of times, a lot of books also tend to show this circuit as a resistor, a diode, resistor, a diode, and a resistor. And this is my CMOS inverter. In this case, a CMOS circuit or an input stage. And this is my pad, which will help me to communicate with the external world. Now see, what's going to happen here is, this is ground, correct? Let's say this is Vx and this is Vy. And in this case also, let's say this is Vx, this is Vy. You can show this circuit, anything. The explanation is the same. An additional resistor is just going to incur an additional voltage drop. That's it. So let's assume a very high positive voltage is applied. A very high positive voltage was going to go to this CMOS inverter, which will lead to its oxide breakdown because of an ESD event. So if a very high positive voltage is applied, we will understand what's going to happen. Ideally, these diodes can withstand or has Zener voltage of around 10 to 12 volts, both these diodes. Here we are talking about very high positive voltage, could be in the range of kilovolts also. So when such high voltage is applied at X, we know that the negative terminal is connected to a very high voltage. The positive terminal is going to be connected towards ground. It is reverse bias. It is not only reverse bias, it is highly reverse bias, correct? And it has also crossed Vz because Vz was 10 to 12 volts. What happens is, it will draw or it would steer the charge away from the gates of the input state transistors, correct? If you have not followed, in simple words, what's going to happen is, now a huge current is going to flow through these diodes because it is excessively highly reverse biased. If you can see, after Zener voltage, a huge current flows. So a huge current will flow through this diode, which means in simple words, it's nothing but a short circuit. So it will divert all your charge towards ground. Why we have used an additional diode is in case the first diode cannot draw the entire charge towards ground, you have an additional resistor which will cross a voltage drop, and again another diode which will steer all the charge to ground, and it will ensure that the voltage which reaches here is a nominal voltage and not a very high voltage. So we saw one of the circuits, very simple, diodes and resistors.